But I have that Reimagine Buildings link ready to go when we need it.
Cool.
Hey, everybody. We'll let everybody trickle in here. Happy Wednesday.
Okay, looks like everyone's in.
Excellent. My name's Tyler Whaley. I'm the internal coordinator for Passive House Rocky Mountains. And this is our monthly meeting. Today we're happy to have Jonah, who's been a longtime Passive House Rocky Mountain member. He's an architect, certified Passive House consultant, and a pioneer in the prefab world with B.Public. Jonah, welcome so much. We're looking forward to your presentation.
Thanks, Tyler. Yeah, it's a pleasure to be here. Piers or helical piers are definitely a big part of my life, kind of a long time ago. So it was sort of fun to sort of step back and visit a previous life. All that. So.
Excellent. And we were so excited to have this as part of the programming that's thinking a little bit about embodied carbon. And we know how big of a piece of the puzzle that is. Foundations involved in it, and the different concrete and things that go into foundations are a big piece of the pie chart there. So we'll work through the normal kind of events, news, and agenda items, and then we'll get on to Jonah. And during Jonah's presentation, you're welcome to post questions in the chat, and we can address them at the end, or we can pick them off while we go. If you take a moment to introduce yourself in the chat and let us know maybe what brought you here and what your relationship to Passive House is, or what otherwise kind of led you to this meeting. News, events, and training opportunities, and then our feature presentation. If you do have a Passive House project that's upcoming or in progress, this is a picture of my backyard. This is my first Passive House ADU. We're building it in the winter because we love pain, but we'd love to hear about it. If you could give your information in the chat and reach out, we'd be happy to feature your project if you'd like to share it, and it'd be great to know about it. There's a lot of amazing incentives in Colorado and the greater Rocky Mountain region for pursuing the training and certification of these things. So please do reach out. We have Kim today. Susie's out, but Kim's back with us, and we're happy to have her. Susie is just out for the day taking care of something personal, but we're blessed with Kim here. Kim, do you want to tell us a little bit about the Passive House Network membership?
Yeah, absolutely. Thanks, Tyler. Great to see you. Great to see everyone. Just here to plug the membership again. So lots of great benefits, including being able to lead the Pier network at the your local PHN chapter. We have 10% off the CPHD course and 15% off all specialized courses. That's new, and we're very excited about it. There's lots of other member resources. We give you slide decks, we give you pamphlets, we give you everything you could ever want. And in turn, you help us keep the lights on, and we're so grateful for all of our members. So if you're not a member yet, please consider. And my email is in the chat if you have any questions about that. We also have an upcoming Certified Passive House Designer course. So that's going to be on April 9th. There's lots of great incentives available. So I'll put the link to this course and all of the financial incentives in the chat. And again, my email is in the chat if you have any questions.
Thank you. Let's see, is Robin in with us today? I don't think Robin is here. So I'm going to speak to the CPHT training opportunities. EMU Building Science has some boot camps coming up, and Enrico told me that there's some really exciting things. Excel is providing a subsidy for architects and builders operating Excel's service area. And I believe this is just Colorado, where they will subsidize 90% of your CPHT, the tradesperson training. So really neat there. And they have these dates coming up. There is a free info session on Thursday, March 6th at 3 p.m. where we can ask Enrico all the nuts and bolts questions about how to utilize those incentives and more about the boot camp. So pretty neat stuff there. I think in May, Enrico's going to come on and tell us a little more in depth about their training program as well. So we'll see Enrico in May. Colorado Green Building Guild's Advanced Training Scholarship Program. This is a rolling scholarship. The next deadline is Sunday, May 4th. It's an amazing program. It helps subsidize my certified passive house designer training. So I'm a recipient of this scholarship, and I encourage anyone interested in these educational opportunities to go to the Colorado Green Building Guild website and apply. Following back up on Excel stuff in Colorado, for my personal project here in Lafayette, Colorado, you need to be in Excel's Colorado Electrical Network. Excel is providing these large rebates for all electric and for high performance. So this little chart here, I kind of put this in here quickly, but next month I'll put a little more information about it. It's I'm going through the process now. It's not secured, but there'll be about $10,000 for all electric, and then another $15,000 for passive house certified. So $25,000 rebate to the builder for meeting passive house certification and having an all electric home that's in Excel's Colorado territory. So pretty exciting stuff. Although Rob Buchanan is no longer with Excel, we have a new contact, and we'll try and have him on to introduce him to everyone. The program is, I'm happy to say that the program that Rob kind of was spearheading is looking like it's alive and well and going to proceed regardless. So good stuff there. Edie from B.Public. Edie, tell us about the Icebox Challenge in New Mexico.
Happy to. Thanks, Tyler. We were really proud to be a part of the Colorado Icebox Challenge. This one is really interesting because it was actually our local home builders association that called us up and said, hey, we're going to do an Icebox Challenge. Want to be a part of it? Which, as you guys know, it usually goes the other way around. And it's a super ambitious project. They're actually working with Habitat for Humanity and YouthWorks, a nonprofit doing jobs training with youth here in New Mexico, are building one box. Our ECHO Early College Opportunity Tech High School is building another one. And then the community college is building another one. So we obviously are supporting the passive house one. And what's exceptional about this one, and I think this is the first time in an international Icebox Challenge, the shells are going to be used for transitional housing at a shelter here in Santa Fe. So they will be donated and they will be purposed for permanent or semi-permanent housing on that nonprofit's property. So I will keep updating this community about that work. Jonah just hosted 18 teenagers from YouthWorks and Habitat today out at the workshop to see what was going on. So no immediate calls. Of course, you can donate. You can support as you want. But just really nice that this is going to happen here. And it's all student built, which is killer.
Yeah,
So thanks, Tyler.
Be at the Capitol building, right, for a couple of months. So it will be totally great. And they're full size. They're 18 feet by 8.5 feet with 9-foot ceiling. So they're full little mini units. It'll be interesting.
I haven't yet convinced them they're going to have to put a lot more ice in there, but you know.
So cool. Yeah, we're excited to follow along. We'd love to see some of the photos as you get going. And if you'd like to flash the kind of design information during one of the meetings, we'd love to check that out as well.
Thanks, Tyler. That's super generous. We'd love to.
Excellent. So I think this is a good segue right into the B.Public events. Do you want to address these, Edie?
Yeah, okay, we're gonna ignore the one in February. That was great. We had a really good visit in our first Albuquerque project. We do have another builder training coming up in March. It's very close to full. But please raise your hand, send a message if you're interested in attending. We are offering it free to California builders who are building in the LA rebuild area. So pass that along to your friends in Passive House who are in California and wanting to support better building back. And I think that's it.
Awesome. So I must have mismade this slide, but I have February 31st here. Was it January 31st?
I think it was February 6th. I
It was a
mean,
really nice event, though. It was
we
great.
could probably do it again. I mean, the really nice homeowners and a killer builder who's doing a great job on it, but no, it passed.
Good deal. Colorado Green Building Guild, there's a event coming up. It's the Fort Collins chapter kickoff happy hour. Greg, are you going to be attending this?
I will be, and we've got a new leader, Karen Ramsey, who's been elected to the CBGB board as well. So she's going to be kind of the FOCO leader. So come on out.
Excellent. Odell Brewing, the North chapter, Fort Collins. There's another event here. A lot of these are on the Colorado Green Building Guild website. If you're looking for the links or more information, so make sure to go over there if some of these pique your interest and you need a little more info or ask for it in the chat. The College of Architecture and Planning in Denver has Elizabeth Babcock, the Executive Director of the Office of Climate Action, Sustainability, and Resilience, as part of their lecture series next week. And they're pretty good about their lectures. I'm an alumni of the college, and there's usually some good stuff. And I think I'd like to attend this personally, but I wanted to throw that out there. It'd be a neat way to connect with her and see kind of all the amazing, ambitious things that they're planning in Denver and how they're approaching it. So be sure to check that out. Let's see, do we have is Johnny or someone from 475 on to tell us about these events? I don't know if we do. Basically, 475 is partnering with a manufacturer of geothermal preconditioning. And I believe the units are manufactured in Lafayette, Colorado. And in March, they're going to be having a series of in-person presentations to talk about the system that's tempering for ventilation. And it looks pretty sweet. I'll probably attend the Boulder one. But if you'd like to learn more about it, please head on over to the 475 website and check that out. Neat, kind of locally made stuff. We have Colorado Renewable Energy Society is doing a presentation on the heat pump revolution and how not to screw up your heat pump. So this is a hybrid event online and in person in Jefferson County. So if you're interested in learning about kind of heat pumps and how to implement them and avoid some of the kind of pitfalls, be sure to check that out. And then Jobert Homes, Mark Attard, and the crew at Jobert will be hosting a happy hour March 13th in Broomfield at the Colorado Cake House. So be sure to attend that and reach out to Mark and Jobert. And it's an excellent way to network and have some fun and enjoy some beverages as well. Real quick on kind of the theme of the beginning of this year, we had Chris Magwood in January talking about embodied carbon in new construction. We have Jonah today from B.Public talking about Pier foundations and as an alternative. In March, we're going to have Ace Arlington from New Frameworks and Ariane from Building Integrity tell us about some straw panel construction and the SEED collaborative program that New Frameworks does, in which they're kind of distributing their manufacturing around. And in April, we're going to have Jen from Builders from Climate Action give us kind of a tutorial on the beam thing. I think the idea for this, we may partner with Colorado Green Building Guild, but this might be kind of a low fee kind of workshop sort of session. So those of you that were interested in the beam tool or have kind of downloaded it and played with it a little bit, this will be more of a walkthrough of the functionality and get to really work with someone who's created it and part of Builders for Climate Action. And then in May, we're going to have Enrico tell us a little more about the EMU training. And then I believe we'll have another presentation on embodied carbon in June. So we got some fun stuff coming up. All right. I think with that, we're ready to move on to Jonah. Jonah, I'm going to stop my screen share here. And yeah, we're excited to hear about your experience. And Jonah has an amazing perspective from an architect, from a manufacturer, from someone who's worked in these different worlds. So Jonah, I'm excited to hear kind of your take on how to incorporate these things and what you've learned in your experience. So welcome, Jonah. Thank you.
Thanks, Tyler. Yeah, thanks to PHN and Rocky Mountain Passive Houses for hosting. It's really a pleasure to be here. And I think, time is a little bit short, so I'm going to do definitely a sort of a crash course in helical pier sort of technology and what hopefully it'll be enough information that everybody can sort of go away with an understanding of potentially how to approach evaluating your project for helical piers. And then we'll go over a couple projects that use sort of a hybrid traditional spread footing foundation to post and beam construction, and some of the things that we've seen from the design and passive house perspective around sort of what to look for, things to maybe pay attention to that might come up on the design. So without further ado, maybe I can start sharing screen here. Let's see, it looks like I got a little ahead of myself, but okay. Everybody see that all right? No, great. Yeah, so piers and passive houses. So I just want to jump into it a little bit. So for about 10 years, I was an AB Chance, certified AB Chance helical pier installer, which it's nothing too much to rave about. There's just a fair amount of training with it. But AB Chance helical piers, there's a lot of types of helical piers out on the market now. And as far as I'm aware, AB Chance is one of the pioneers of the helical pier design and engineering. And they're the only ones on the market that are truly pre-engineered. So if they're installed to specification, then there's no other additional engineering. So an engineer would just specify what the load capacity needs to be at a single point, and then that AB Chance helical pier installer can go out, install that pier to the manufacturer's specifications, and that's it. So your local engineer doesn't have to necessarily engineer the size of the shaft or the helix or anything like that, which is really beneficial. And they did this because they developed the technology for installing helical piers, really for power and transmission pole installs, right? So helical piers work in compression and tension with equal capacity most of the time. And so, those big telecommunication lines that you've seen going across the middle of Nevada, those are all pier foundations, basically. And so they're able to go and install those foundations, really consistently without them doing soils testing and geotechnical at each one of those points. So that's really where the technology was developed. So what's really kind of interesting about them is that so the amount of torque that's required to continue screwing the pile into the ground has a direct relationship with the pier bearing capacity. So, and just a little bit about terminology, I'll probably be switching back and forth from pier to pile, but so they're identical, same definition. I'll just kind of switch back and forth sometimes. And so this is showing what some typical AB Chance helical pier capacities are. So this is probably these SS5s, which is an 1.5 inch shaft, which is what most likely you're seeing in this picture here, installed to this torque of 5,700 foot-pounds of torque, would have an ultimate capacity of 57 kips. So 57 kips translates to 57,000 pounds, basically. So for some reason they talk in kips where they could be talking in pounds, but in that ultimate capacity is the pier itself, and then there's also a rated capacity where there's a safety factor. So just reaching torque for installing pier means that pier has reached its maximum bearing capacity. So you can see these ones up here, it's 2.25 inch diameter. We're at 210,000 pound capacity. So just absolutely enormous capacities for these piers. And that'll come into play when we talk about sort of optimizing foundation design. It's important to understand the capacity of the pier so that you can sort of balance. You want to use the pier for close to its ultimate capacity, right? Otherwise you're installing a lot of piers and just far more capacity than you really need. But on the other hand, you need to span from that pier to pier, so your beam economics is impacted a little bit as well. So this is how the quality control or the shear or the torque is monitored when you're installing a pier. There's two different types, and this is the hydraulic drive head that's attaching to whatever hydraulic compressor you're using to operate the machine. And so there's a digital torque indicator here, and it's just telling you exactly how much torque is needed to continue installing that pier. And again, there's a direct correlation between that torque and its holding capacity. So say if I had a pier that had, if installed to a full capacity, had 100,000 pounds, I could install it to half that torque and I would have half that capacity. So I don't have to install every pier to its full capacity. Again, so it gives a lot of flexibility in the field. The other way to doing it is using a shear pin torque indicator. So just each shear pin is equals 500 foot-pounds of torque. So you're just inserting the pins that you need. You're screwing in that pier until that just torques off and it sort of stops spinning. So that's also your indication that you've reached your desired torque. And so again, therefore your desired holding capacity. We were talking a little bit earlier about sort of the ultimate capacity opposed to a rated capacity. So typically a 2-to-1 safety factor is used. So if I'm using, probably the most common shaft size is 1.5 inch square shaft installed to its max torque. It has a 57,000 pound ultimate capacity. It's rated then for 27,000 pounds. So again, pretty straightforward. But so this the quality control when it comes to pier install is largely reliant on these just the torque indicators and documentation of the torque required for install. It's kind of interesting, we've installed I've installed hundreds of helical piers. A lot of them were actually doing structural stabilization within the interior of a building, in which case we're using, what would be called handheld equipment, which is, pretty interesting. You're not installing the larger piers with that handheld equipment, but it means though that you can, bring this cart down to your backyard and install a foundation for an ADU or something like that. So it's really good to know that pier install can be done with very small equipment. And so it's a great way of installing a foundation for an ADU or a remote project or something like that. Most of the time you're utilizing a smaller bobcat like this. Has plenty of hydraulic pressure out of a bobcat to install even some of the most largest piers. And then, larger equipment is fine too. I'd say 90% of the time though, for residential construction, just because you have access, a bobcat is just fine using it. Installing. So when in terms of sort of pier design, there's a lot of different options that have sort of subtle impacts on their overall performance. So one is just the helix option, and they come in from 8-inch diameter like this one here all the way up to a 16-inch diameter. You could also have, these are called lead sections, where it has the helix. And it's basically just the lead section most of the time that has the helix, and then the rest of the shaft, say as the helix, the pier goes down, it's just extensions of that steel shaft. Rarely are you installing additional helix along on extensions. And then you have units that have these sort of graduated, so multiple helix on them. And then we also have variation in the diameter of the shaft. So there's solid square shafts up to 2 inches or 2 1/4, I think. And then up above that, it goes to hollow round shaft up to like 3 1/2, 4 inches, I think. So the reason that you'd be wanting to use, say, multiple helix or larger ones is that helix is responsible primarily for generating the resistance as you're driving that pier down. So if I have loose soils, then I'm going to want to potentially increase the number of helix on there, so I generate torque or that resistance earlier. So say if I had loose soils and I just installed a single lead section with a small 8-inch helix, I could maybe be going down, 25 feet, 40 feet before I had actually enough density or pressure on that on the helix in order to achieve torque. And your cost for a helical pier is largely impacted by the depth of that pier. It can also be impacted by how complex that lead section is, like the number of helixes on it. But typically, it's by weight for the most part, and it's that shaft that has the most weight. So your longer, deeper pier is going to cost more in general than a shallower one. So economically, I probably want to try to hit torque or reach my my bearing capacity earlier than later. So it might mean that I decide to use a pier that multiple helix lead sections, so I get that torque shallower. And then really the what impacts your choice in the diameter of the shaft has to do with slenderness buckling of the pier. We'll get into that a little bit, but say if you're doing a project where you actually want the shaft of the pier to extend out of the ground 4 feet or something like that, then potentially I'd be using this, thicker diameter pier, so that I have that lateral resistance or that rigidity in the unrestrained portion of the pier, which is the section of the pier that's above ground level to the bottom of your building. And we'll get into a little bit more about that in how the soils types also impacts that overall shaft selection. So again, I've installed hundreds of piers, and I would say 90% of them we're using just an 1.5 inch shaft with a single 8-inch helix. And almost all the time we would meet that max torque around that 27,000 pound capacity at around 12 feet. It was amazingly consistent, honestly. There were, of course, exceptions. Sometimes we go down 75 feet or something like that, but most of the time you're hitting torque at around 12 feet. So let's just talk about sort of the impacts with soil selection. And one thing that's important about this is the geotechnical work, or having your geotechnical engineer design your foundation, I think is, becoming more and more common, potentially just from insurance or liability concerns. But one thing, when you're using helical piers, like, we're not needing a geotechnical engineer to design your foundation. Like, really what you're interested in is having a sample taken on site. So you just actually want the data of the soil type. You don't actually need an engineer to then take and interpret that information. You just want the data. So a lot of times that soils investigation just for a soils bore log can be a lot cheaper than hiring that geotechnical engineer to do your sizing of your foundations and so forth. So this is what a typical bore log is going to look like. And for those of you who haven't seen it, this is just your graduated depth right here, and it'll just show you how deep they went. They'll take samples just for observation as they go down. And so they're just sort of classifying it like it's stiff, red, orange, gray silts. This is medium to very fine brown. It's like they're not doing sieve analysis of it or anything like that. They're just doing basic descriptions. The important part that they're doing, though, is that they're doing what's called a blow count, or your standard penetration test as they're going, which is, it's just as archaic as most ASTM standard tests. It's taking like a 10-pound weight and dropping it 30 inches, and it's dropping it multiple times to see how many drops it takes for that weight to sort of compact the soil over a certain distance. So what that gives you is, it gives you what's called like a blow count, or again, a standard penetration test. So that N is your blow count. And so the higher the number, that denser that soil is. So you can see down here at the bottom, they have a blow count of 28. Up here, the lowest is right here around here in the 7. So what you need to install helical piers is just anything that's over 5 will provide enough rigidity with the soil on both sides of it to hold that shallow, or that sort of narrow steel shaft in its vertical position. So if you have really loose soils that you have a blow count of below 5, and that sort of loose soil extends for more than 10 feet, then you have a risk where you have slenderness buckling in that shaft. So if it was fully loaded, potentially that shaft then would buckle, right? And if I had a test that came back and it has a good section that's less than 5, then I'd think about installing a thicker pier shaft in order to be able to sufficiently resist that slenderness buckling right there. And so again, there's other ways, like I can hit like in bearing, or what's called refusal. If I'm going down and I hit a rock or bedrock or something like that, where the pier will just spin in that situation. And that can be fine. It's just that you're not using your torque to determine your bearing capacity. It's really then the overall sort of slenderness, buckling, or resistance of the shaft itself. You can also hit refusal, say if I'm trying to install a pier using that smaller handheld equipment, and I just don't have the weight on the top of that pier in order to sort of catch that helix so it's screwing down, can also sort of spin out in that situation. So technically, like the minimum depth for a pier is going to be 5 times the diameter of the plate of the helix. And so that plate needs to be a minimum of 5 feet, 5 times below the ground surface level. Just in general, like I think 5 feet is sort of a good rule of thumb, just sort of on a minimum basis, just because you're wanting to have that helix sit down in a strata of soil that is stable from a moisture perspective, from a frost perspective, and things like that as well. So In terms of brackets, there's a really tremendous amount of different options for the top bracket. So you can see this is for a new construction bracket where I'm just laying my rebar and it's just being cast right into it. This is really common use for helical piers actually is just being installed down the bottom of a trench where a grade beam is poured just to basically provide bearing for that grade beam, so there's no spread footing. It's just really it's supplying the support for that stem wall. Slab bracket, again, just for a lot of remediation and structural settlement in buildings. And then there's new construction brackets. You'll notice just the difference that you'll have through bolts that are connecting to the pier, just to resist uplift. And then they have beam brackets as well, and then beam brackets with lateral support. So as we were talking about before, like helical piers have the same capacity in pull-out resistance as they do in compression. So a lot of times you're installing a pier in order to provide lateral resistance. You're just installing a pier at an angle like that and then connecting to it. So I would say in most of my experience, we were designing our bracket custom based on the project. We weren't necessarily, unless we were using for new construction and it was going to be cast in concrete, but almost all the post and beam projects we've just designed a custom bracket that just fits on the head of that column. There's just lots of different reasons for that, but most of the time that helical pier is coming up again pretty close to the top, just to the surface. It's getting a pad of concrete at that section and then another steel column that's maybe quite a bit more rigid, that's able to resist that lateral load and so forth up to my building. So lots of options. So the other type of foundation is, and this is really taking me back, and I have to apologize for the quality of these pictures, but really this was like 18 years ago or something like that. So it's kind of fun. But so most of my experience doing helical piers was in actual structural stabilization of earthen architecture. And they do have a lot of really neat brackets for retrofitting on existing foundations. We were having to develop, some technologies where, trying to install a pier onto a point that really can't be point loaded. So we were developing a lot of sort of basket designs where the pier would hold onto that basket and then just would stabilize the earthen foundations. There's lots of earthen buildings that just have rubble foundations or no foundations at all. And a lot of times they were in great shape, but if they were, got saturated or something like that. But so helical piers are really amazing from an environmental perspective, the same reason that they're so great from a historic preservation perspective is that, there's no displacement with helical piers. So I can install a helical pier, come back in 10 years, and then I can unscrew that helical pier, and all that's left is just like a little 2-inch hole. So it's really amazing how reversible and simultaneously potentially permanent the foundations are. And just there's absolutely no soil disturbance besides the equipment that you're using to install that pier. And so they're really well suited for historic preservation projects. And there's maybe one of my favorite projects was this one that we designed and installed this helical pier foundation in the Salisbury Cathedral Close, which is this school is just right off the picture right here, but really an amazing location, as you can imagine. We had sonar scans of all the ground where you could see all this Roman era foundations that were still in this area. There was everywhere that you looked, there was like little clay pipe stems and things like that. It was just such an amazing archaeological site. And because of all this historic masonry construction, we couldn't cause any vibration, so you can't use, vibratory piles. And, concrete was prohibited as well, just because everything needed to be reversible. And this site also sat on this like 30 feet of sort of this bearing strata that we needed to hit bearing on. And then below that was just thousands of feet of this decomposed chalk, basically, which was just sort of like a big puddle. So we had to design the piers to be able to bear and provide our loading capacity within that 30 feet. And so in that situation, sort of as we were talking about before, like sometimes you're just wanting to go down and reach torque whenever you can, but if you really can to change the design of your pier to, if you know what your soils types are, to found or sort of reach bearing capacity really exactly where you want to in terms of depth. So in this situation, we knew exactly how far we wanted to bear, or at least we knew we didn't want to go past 30 feet. And so we designed, using these 3.5-inch hollow shaft piers that do develop quite a bit of side friction as well. And then we had multiple Heelys as they went down. It was a really fun project. It was funny. The first one we installed, we worked with this English engineering firm to develop our torque monitor and so forth. The first pier we installed, the engineer, the architects, like everybody in the whole project was all there, so excited for us to install it. And first pier we installed just went right down through our bearing capacity. It's like I had an absolute moment of panic, but it turned out there was just a difference in our conversion from metric or for IP to or imperial to metric on our torque monitor. So it worked out, but it was a really fun project. And again, just I think shows the potential of how much design work actually can go into a helical pier foundation, but also at the same time, they also don't require that level of design if the project doesn't require it. So really pretty neat. So let's just go into just a little bit of sort of design and I think performance optimization for, and this is really generic to, I would say, post and beam foundation. So, helical piers are a great way of installing, bearing columns, but there's a million ways to do it. And it's sometimes appropriate for you to have a 2x2 concrete pad going up to a post as well, right? So, but I think the main difference when we look at environmental impact that we're sort of after, it's more about post and beam construction than it is helical pier, foundation. So post and beam foundation is just allowing you to reduce the amount of concrete, replace that concrete with a material that is much more environmentally sustainable, like frames, floor panels using cellulose or, something like that, where your carbon is being sequestered opposed to it's spent. And post and beam just in general also is just reducing how much site disturbance, disturbing grading and drainage and the other sort of responses that we all need to do in order to restore an environment from that soil disturbance and so forth. So again, so we're going to be just sort of switching a little bit to post and beam discussion rather than helical piers. So just my sort of a last note on helical piers. So again, the engineer would be, say, if this is your project and this is sort of representing our optimized project, what you're wanting the engineer to provide, if you're wanting to use, helical piers, is they just need to tell you what the ultimate load is needed at each one of these points. Then the helical pier installer will install the appropriate pier with that capacity, and they'll give you a piece of paper that says, this pier is installed to this torque with this capacity. And so that's just important, opposed to the engineer saying a 4 foot by 4 foot, 10-inch thick footing or something like that. They need just specify what that ultimate load is. So looking at sort of an optimized assembly, the geometry is allowing for consistent pier spacing. That's going to just allow, consistency on the piers that are being required. It's also going to allow for a consistent span. So my same beam type is going around the perimeter. That's not going to be that much of a difference for the beam itself, but it is when we have different beam types, then we have really complex connections between these, whether they're steel or wood or anything like that. So as any builder knows, like two beams of the exact same dimension coming together, that's a very easy connection in a lot of different ways. But if you're needing your architect or engineer to customize, custom design specific hangers for different beam depths and so forth, it's going to be expensive on the design and engineering side, and it's going to be a pain in the butt in the field as well. And then really trying to optimize design, like having some meetings with your engineer about how far of a span can I go with this bearing capacity if I want to use the most reasonable pier out there, which is that 1.5 inch square shaft, say 27,000 pound capacity. Like how far can I go? So really, you really can optimize your design with that knowledge right there. And then looking at, just because you can span, and we talked about this, just because we could span, or just because our pier can hold up to 200,000 pounds, doesn't mean that we necessarily want to have a beam that can span that 50 feet all the way across, right? That's an expensive beam. Maybe it's a really big beam, it's sort of, then you have diminishing returns on the rest of your supportive structure, even though you've optimized your pier foundation. Like, great, I've got 4 piers, but now your other secondary structure is just really expanding. So just paying attention to that. And also, so again, just early conversation with your engineer, what kind of loads are you going to be looking at? So this is sort of an unoptimized scenario, of course. And so what's happening here is, I've got different spans. So you'd be faced as the architect trying to do a good job, both for your client and for the environment and so forth. You're going to be asking yourself, like, well, do I want put another pier here? I don't really need it. I could do another larger beam across this way. Same with this, like, you don't necessarily need another pier here. I could just have this beam, and this other smaller beam could just T-bracket into it and so forth. You're going to start having these really sort of subtle evaluation debates that's basically going to be in your own head, because you're not going to know until you price it out and so forth, right? And it just gets down to the point where you're just sort of splitting hairs. It's just going to be really difficult to optimize it. In just these smaller complex intersections, though, just because we optimize it from an architectural perspective, doesn't necessarily mean it's optimized from the builder's perspective too. So just paying attention to that a little bit. So again, like, these green piers are sort of representing these piers that you might not need, but there's what sort of economic analysis is required in order to determine that. And then some of these lighter piers, like, these are very small loads, right? So very small loads, but your design is necessitating bearing capacity at those corners. But now you've got a very relatively expensive pier to just hold up 800 pounds. Like, so your economics are starting to sort of diminish right there from a pier foundation. And that's, of course, where you want to optimize your design to the construction approach, where there's just not enough slop nowadays in our industry to be able to design a house and then figure out what kind of foundation you want to put on it, right? Like, we want to know really what's the most appropriate foundation, what's the most appropriate wall assembly, roof assembly, and then you're really sort of designing to those assemblies. And then it's even more so with pier foundations. So getting into systems a little bit, I'm just going to go pretty quickly here. So really consider your waistline elevation drops, because this is my floor panel now. So your waistlines are needing to, in all likelihood, they're going to be dropping down below your joists, right? And so in traveling, and so just paying attention to that. So say if this is a wet area and I have a drain that's needing to cross, if I've got a beam across there, now I've got a conflict, collision between that drain line and that beam. And so there's so many redundant benefits from consolidating our plumbing already. When you go to a post and beam foundation, those benefits are even compounded even more, I think. So really, just because again, your plumbing lines, your drain lines are going to be outside of your thermal envelope, and you're going to need to protect or cover them or something somehow. It is totally great, though, to be able to vent down everywhere, honestly, for passive houses or your ERV and dryer and so forth. It can be totally great. And it's so nice, too, because you say if you're venting down, you're not worried about snow accumulation clogging up that vent or anything like that. It's like it's just kind of a nice protected space. Think about, you're wanting to eliminate as many lines going through that floor as possible. Just for the same reason you typically don't want to put your water supply lines in an exterior wall. Same thing, you're just not wanting to put it in your floor now, because your floor is really your primary thermal envelope. So there's just, opportunity for risk there. So think about running them in your interior wall and around service cavity of exterior. Your drains and your water supply line are going to have to come into the house someplace. So looking at consolidating that, if possible, and then just really making sure that you've got access to that space. It's nice to have access from the exterior underneath, rather than trying to build a trap door down that's passive house, like that's airtight and everything like that. Which means that it needs to have enough vertical space that you can access that area, right? Even if you're insulating those water lines and those drain lines massively, it's still, you've got 50-degree water and it's 0 degrees outside. So your insulation's not doing a whole lot, because there's not a whole lot of warmth there to protect, right? To isolate or resist against. So think about doing something just for a little bit of protection, potentially adding heat tape or something in that area. Not that it's functioning anytime, but like if anything did go on, that they could, plug that in and protect it. Can also do one thing that we've done most is create like a little masonry plumbing pit that is super well insulated on the inside, and then just had like a light bulb in that area that would be controlled by a thermostat. So it doesn't take, really, as we know with passive house consultants, doesn't take a lot of warmth to bring that temperature up if it's really well insulated. So from a thermal perspective, just to remember that your floor R value is really going to be increasing just because of the exposure to ambient temperatures. And a lot of times it's going to have a lot of wind washing too. It might not have the same finishes or protection from wind washing that your exterior wall or your roof will, right? So if you're doing stucco or siding, that's a really pretty good protection against wind washing. But if you just have a light membrane at the bottom of your floor or something like that, wind washing will have a bigger impact on it. So think about sort of playing with that in the PHPP if you're modeling it, sort of opening and closing that exposure so you can see what that implications would be. It does, that insulated floor just makes all your thermal bridging and your thresholds and things like that so much easier to address compared to going down onto a masonry foundation. And again, for the wind washing and so forth, just, continuous weather barrier on that underside is really important. Some other things just from a, say, architectural perspective to really think about, leading up to a project. Now that you're building, say if you've got wood beams, I've got 16-inch separation minimum between my soil and the bottom of my wood beam. I've got a 16-inch wood beam, and then I've got my floor assembly. Really quickly, your finished floor is 3 to 4 feet off of finished existing exterior grade, right? So just making sure that your overall plan and accessibility requirements are able to be adapted to that situation. And there are, of course, ways that you can can alter that and so forth, but as we know, those things can get expensive. So just make sure that you're maintaining your ground clearance and while avoiding, creation of habitat. So you don't want to create a post and beam foundation where it's unskirted foundation that's creating, there's just sort of great warm areas for raccoons or skunks and things like that. Just pay attention to, you want that to be exposed. You want people to be able to see it so it can get cleaned out. Fire resistance, that's, the bottom of your floor now is potentially exposed to exterior fire. So just thinking about budgeting, putting either cement board, or we've done like corrugated metal roofing on the bottom of it, but just think about that. And lateral bracing is kind of a big thing. In the projects that I'm going to show you, you'll see how we've addressed lateral bracing, but depending on where you are and how heavy your building is, or how tall it is, or how asymmetrical it is, that lateral bracing really can be a beast. So, so again, early conversation with your engineer. So these are two projects this is one project, but I'm going to show you two projects that use, again, sort of these hybrid approaches to post and beam construction. This project is just less than 10,000 feet elevation in northern New Mexico. And it sort of minimizes the continuous foundation, uses some cantilevers and post and beam construction. Again, just trying to do the best we could within our sort of parameters. And it's a pretty short building site season. This is that foundation, so it's using actually these big glue lamps running through, and so this side of the building is cantilevering. And then it's got post and beam, and then a little bit more cantilever. And then it's got some masonry foundation. And you'll see right here, this is actually our mechanical enclosure for this. So we dropped all of our drain lines and everything like that in that side. And that's what we had access to. And then that just got a lot of continuous interior insulation. Just it's showing an example of, that steel bracket. Again, those were pretty simple, but custom. This is the ventilation system install. So it's so much fun, again, to be able to sort of go down anywhere in your floor plan, opposed to having to, I'm worried about exhausting too close to the front door, or too close to the bedroom, or kind of like that, like all these sort of design considerations. It's really nice to be able to take that stuff in and out so directly from that floor. So in this situation, it's just coming down just adjacent to that plumbing pour, and then just going to the exterior there. So here's another project that's also in northern New Mexico. It's probably around 7,000 or 8,000 feet. And so I guess the other project you saw, like part of that is masonry. So we're handling our lateral resistance by grounding a portion of the building that also relates to the plumbing pour, right? So we're using that sort of that masonry column for structural lateral resistance as well as our system protection. And this project is doing the same thing. This little blue rectangle right here, and this comes down to the design optimization as well. So this little blue rectangle, this is what contains all the plumbing. So this is actually the masonry section of this project. And then the rest is post and beam off of that. So the project is, retained and laterally resisted from this. It's got most of our mechanical supply and so forth. And then it allows just a lot of sort of fun freedom in that thermal envelope design going out past that. So thank you. That was Okay, we've got 30 seconds for questions.
No, as long as you don't need to boogie immediately, we can bleed over a little bit. We do understand.
No, I'm happy to. I'm happy to.
Jonah, that was amazing. I've used these Piers a little bit in my own practice, and have explored them with some architects and engineers that are on the call and builders with us. And I learned so much that I didn't understand there. We do have some excellent questions. I think kind of just starting off from the top is, you know, there's a few questions about kind of like the viability, and I didn't understand the sort of in thing, and maybe we could talk about that a little bit later. But basically, what happens if you hit bedrock and you don't torque out? How do you proceed from there?
You're fine. It's just what the capacity is controlled by the capacity of the shaft rather than the torque. But that shaft is designed to provide the full capacity of that pier, of course, right? Because whether that helix is in the soil, it's still, that load is still through that shaft. So you've still got 100% of that capacity. The thing that you want to be a little bit careful of is, say, if I hit refusal in what I knew to be like a smaller, like rock field or something like that, you want to just be really sure that you're hitting true refusal and that you're not just hitting like a 1-inch rock that you know, that your equipment's not allowing you to pressurize down through it. But most installers really, that's something that we came across all the time, and there's lots of things that you can do about it. Sometimes you can move your pier over a foot or something like that too. Like if you can test to see like how big that rock is. Yeah, and so again, like you're just not wanting to hit like a smaller rock that's kind of shallow that could be just surrounded by clay, basically. So
Excellent. Along with that, Kyle had a question about the soil information, and you touched a little bit on it. And I thought it was interesting that you don't need the full-blown geotechnical report with the engineering recommendations for foundation. And just to clarify, it's you would tell your geotech engineer that you don't want those things, and the reason you don't want them is because those are going to be provided by the Helical company, the Helical installer.
yeah, or I don't think there's any reason to tell the geotechnical engineer why you don't want something. You're just specifically requesting like boring test for, you know, for your site. And a lot of times you'd want to do maybe 3 of those across, like in a triangle across your building site, just to make sure that you have consistency in it, right? So if I do 3 tests and one of them's totally different than the other 2, then that'll give me a little bit of concern about, well, what I'm going to be hitting. But if both of those are very different, but they're still really good soils for founding a pier, then it doesn't really matter. But again, I don't, it's not about why you don't want that service. It's just that it's a very different, like, so typically you'd have, that bore testing is done by a company. That company provides that information to the geotechnical engineer. The geotechnical engineer evaluates that and provides a foundation design. You're just skipping that last 2 steps. You're just requesting, I want like a bore sample for, you know, for this location down 20 feet or something like that. So
And the Helical contractor is providing the analysis on it as opposed to the geotech.
yeah, and they're going to make recommendations. They're going to say, like, say if you do have that soils data, they're going to make recommendations like, you know, I think we're probably going to go down 20 feet. I'm going to use this kind of pier. And that way it'll help them give you a much more accurate quote when you're asking for a quote. Like, again, if they know there's relatively loose soils, then they're going to install maybe a slightly more expensive pier with multiple Heli, but it's going to be only 12 feet deep or something like that. It'll just allow their bids to be more accurate. Because they're going to estimate, they're going to say, we think we're going to go down 12 feet or 20 feet. They're going to base their bid on it. And then they're going to say, for every foot past that, it's going to cost $5. It's like drilling a well or something. So they're not, you're on the hook if they go down 100 feet. You know what I mean? Like, so.
Subway prices, I like that. $5 a foot. Used to be that.
Yeah, exactly.
You've had a question regarding torque. If you don't hit torque and you sink your pier, what do you do there? Do you stack another one on it, connect another, and keep going?
Yeah, so the lead sections come in lots of different lengths. The standard one is 8 feet. So, and it has sort of the top of the pier is just a square with a hole in it, and then your extensions are basically just like a ball connection that goes over it, and a bolt goes through it, and you just keep on going. And it's just like drilling a well. You just keep on driving it down, keep on adding extensions as you go. Yeah. And then you chop off the top of the pier wherever you want it once you're done. Yeah.
This is kind of a follow-up question about the bedrock situation. Could you remove a pier if you hit bedrock and replace it with one with more helixes in order to torque out? Do you ever do that? Does that ever happen?
You could do that. You absolutely could. And you can remove them. Yeah, it's not a problem to remove them. It just depends on if that bedrock is down 6 feet, you're going to have a hard time reaching torque before it. You know what I mean? But if that bedrock is down 30 feet, then it would be a good idea to switch that out and put in a larger helix or something. Yeah.
And if you do hit refusal, how does that affect your uplift rating? How do you determine it if you hit refusal?
Yeah, really good question. Your refusal, you would lose your uplift resistance, or your uplift resistance would be equal to the torque that you had installing to that point, basically. Yeah.
Gavin had a question
if I
here.
wanted greater resistance from in tension, then I would want to install a larger helix down to that point. Even if I was going to hit refusal, it would just give me greater tension resistance. Yeah.
Right. Gavin had a question about how tall piers can extend upwards typically. The second example showed a full raised story. What are kind of the limitations there, or how you approach the height of the pier extension?
It's totally based on the project. I mean, because it's seismic and wind, mostly seismic, that's going to control that resistance requirement. Like in the size of the shaft that you've got there. So that is just completely variable.
The Ranger had a question about concerns about the longevity of helical piers in comparison with concrete footings. Are these eventually going to degrade due to rust, or what's the lifespan for these foundation systems?
Yeah, that's a great question. And you can imagine that's a real concern for a lot of people. They've got a tremendous amount of data on them. Like, so they're all hot dipped, galvanized, and I don't know offhand what the actual lifespan is on it, but I know it's equal to or equal to concrete. You know what I mean? They're doing it for a really long time, but they've got a lot of data on it. And I would encourage anybody that's interested in more technical information to go to the AB Chance. Hubble is actually the parent company, so it's Hubble AB Chance website, and they have a tremendous amount of information, including corrosion resistance and so forth. And a lot of times these piers and it's a different kind of corrosion, but these piers they're installing, like, it's what holds down like our communication cables at the sea floor and things like that, right? They're in, that's what they were, originally developed for as well. So some pretty gnarly environments that they work in.
Excellent. Let's see. And then Edie put a neat note in here just so folks know they're going to be at IBS next week. So if you're going to IBS, make sure to stop in and have a beer after the show with them and continue the conversation. Another great question here about diamond piers or pin pile foundation systems. Are you familiar with diamond pier ground frame or surefoot footings? These pin style ones, and do you have any thoughts on how they compare to helicals?
Yeah, I am familiar with them, and I think like there are some really cool foundations out there that are using sort of the same sort of empirical data that helical piers do. Like, and they're really neat. They make them for installing, porches and signposts and all sorts of things that they're great foundations. They just tend to have a lower capacity. And again, in my understanding, AB Chance are the only ones that are truly pre-engineered. Like, so again, if installed to their specifications, to the torque, that you don't need any other additional, engineering. Where a lot of the other piers that I see out there, they're being designed and made for, again, porches and signposts, things that don't require, engineering necessarily.
So. And how appropriate are these types of systems for something like the B.Public prefab panelized stuff? How well does this marry with the B.Public approach?
It's it works really well. Like B.Public's sort of watchwords are around like sort of efficient install and sort of environmental protection. So I think a lot of our model homes are designed to use prefabricated floor panels, which when you're using prefabricated floor panels, just being able to set them down onto parallel beams, there's just no, more efficient method of construction. And like post and beam construction is identified 100 years ago as the most efficient form of construction, right? It really, really is just phenomenally resilient when it comes to different topographies and soil types and architectural styles. And so maybe Edie has some more to say on that, but we've done a lot of projects utilizing post and beam and the B.Public panels. It can go great. I think there's from a passive house perspective, there's places where say in Albuquerque where I have more cooling than I do heating, or a balance of cooling and heating. When I have that balance of cooling, there's a lot of benefits in the Southwest to engaging in this the connection to the ground and utilizing reducing your insulation between the ground so that you can sort of balance the sort of the heat sink that the earth has to offer, mass from the say a concrete floor or something like that. And so where I see the post and beam and higher insulation floor assemblies really working, they tend to be in colder climates. So I'll just say that I wouldn't necessarily do it in Arizona unless I'm really wanting to do it from an environmental impact perspective. You know what I mean? So again, just evaluating it, from wearing multiple hats is probably a good way of going.
Yeah, it definitely aligns with our ethos of what's appropriate for each project and having that kind of flexibility. I mean, it is, having point loads and being able to use our floor panels is great for some of these rural projects where it would be prohibitively expensive to do it in concrete, and you'd have to, mow down half of the hill to get in there. So it's just a really nice option. You know, it's component based, just like our panels. There's something related, isn't there?
Mhm.
Yeah,
Yeah,
certainly.
and they are really way more predictable in cost, honestly, like, which is really nice. I mean, they're, you know, a Pier foundation will usually go in a day. Like, so it's just, and so you're really, the primary expense is the materials needed. And a lot of times they're very good at estimating what is required for the piers. So again, it's like sort of as Edie was saying, for sort of our ethos, predictability in the building market is something that we actively pursue, and any opportunity to take advantage of that, we really, we do. So.
Excellent. Well, awesome. Well, we've run over a little bit, but I want to thank everyone for joining us today. And Jonah, I want to just huge thank you for the thorough and amazing kind of 101 and beyond on helical piers. I learned a lot myself, and I'm personally really excited about integrating them into my practice. And having just gone through a typical kind of foundation and seeing all the digging and diesel and
Yeah.
eruption and
Yeah.
concrete and form boards and curing and weather and all those things, I'm just stoked to do the next, at least give a really good analysis on the next few projects towards this, and it's helpful to me, and I know it's going to be helpful to everyone. So thank you so much.
Yeah, and I just want to throw it out there, like anybody's, I love helical piers and stuff, like, and if anybody's interested, you know, has a project that they're looking at for it, like, please feel free to get in touch. I don't install them or anything like that, but I'm really happy to talk over somebody's project, at all. So I'm happy to nerd out with anybody anytime. So.
Excellent.
Okay.
Well, cheers, everyone. Yeah, have a wonderful rest of your Wednesday, and come join us again next month, and go see the B.Public folks at IBS, and you guys travel safe.
Thank you, Tyler. Thank you, Kim. See you all.
Yeah, thanks all. Until next time.